Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Hi, welcome to Homework Hotline. I'm Ken Pinkerton. I'm a retired science teacher from Zane Middle School.
And my name is Reada McConnaughy. I am a math teacher with Northern United Humboldt Charter School, and you're watching Homework Hotline.
Woohoo! And we've gone worldwide, so we're now on the web. So if you have a question or if you want to watch us on the web, you go to homeworkhotline.tv and follow the links there. You can message us your questions now rather than call them in. And the neat thing is we are literally all over the world because we're on the web, which lets me say hello to my big brother Daryl, who's in Southern California. So I hope he's watching too. So, and he's doing well. So, and then we have an exciting announcement. One of my favorite events of the year is happening this Friday, which is Science Night at College of the Redwoods. Yay. It's free. And it's really neat because the all the science departments, the auto and the engineering departments, so you can go in and check out the auto labs and the engineering and the machining. The nurses program and the dental hygienist program have a lot of cool stuff going on. There's chemistry magic shows that are quite exciting. See some explosions, some cool color changes, neat stuff with bubbles. And like I said, it's all free. There's going to be a taco truck there this year, and the cafeteria might be open too.
Awesome.
So, and I think it's the best family event of in Humboldt County. So
starts at 5:30.
Starts at 5:30, and I think it goes till 8:30. So it's
parking.
Parking is free.
Okay.
One of the few times it's free. So check it out. It'll be fun. I'll be there doing fun with physics. We'll show you on Thursdays some of the fun stuff we'll be doing. Big scale. We'll do it small scale here. So send us in your messages. So and in the meantime, since we had the power outage last week, right?
Oh,
last week, that
Wednesday.
made me think about candles and so I thought there's some fun things we can do with combustion. So combustion is a chemical reaction, and it happens. Normally, we think of it happening pretty fast. Combustion means something's on fire, but it can also be really slow. If you have rust, it's also like a rusting nail or your rusting car. It's also a very slow form of combustion. Traditionally, we used to call it the fire triangle. You can see on your screen it was the oxygen, heat, and fuel. But lately, they've changed it to the fire tetrahedron because what has to happen is a chemical reaction between those three things. And so we're going to show you some chemical reactions today that are kind of cool that happen. So you caught me looking at the screens.
Which one?
In the middle is a chemical reaction.
Chemical? Okay.
Chemical reaction, yeah, there it is. Or it says a chain reaction, actually. So, and like I said, sometimes it can be very slow, like rusting or like silver turning colors. But that would be really a boring show
to watch something
this nail rust. And so we're going to play with fire. So what we're going to do is put out these first. I'm going to show you some neat stuff. With just candles.
Some little birthday candles.
We got 3 little birthday candles.
Need some
and
fire.
We're going to light them, please. Yeah, go ahead.
Let's see if I can do this.
You have to push on the button, I think. Or no, maybe not. And light those 3 too.
Those, okay.
Yeah. Okay.
Oop. All right.
All right, so this is kind of one of those no-brainers. We're just going to watch them burn for a little bit. So they're burning fine, right?
Okay. Yep.
Okay, so now what we're going to try, let's see how adept we are, is you're going to take one of those. We're going to, you can use the bottom. We're going to put them, these are just our handles, so we can put them in without dropping them. Okay. And we're going to put them in these glasses all at this, try to do it at the same time. So you can see that they get smaller as we go. Okay, so let's do it and see if there's any difference. So ready? 1, 2, 3, we'll put them in. And I think this hopefully
so candles inside
this will be boring too.
So we're watching a candle inside of A
3
glass.
containers that are not doing anything. And
Okay.
if you're doing candles at home, especially if the lights out, candles are a major cause of house fires. So you should always have them protected, not just having them that way, and have your animals away from them too. So you can see they're burning fine. Now we're going to pull them out.
Okay.
Okay, and we're going to pull off our sticks, kind of put them in the same order. And now this time, where we're going to try, so put it back up there, please,
Okay.
is you're going to put that one on. We're going to see what happens if we turn them upside down. Okay, ready? 1, 2, 3, put them on. Well, hopefully they won't break.
Yeah, what if...
Oh, that one went out. Little one, middle one's going out. You can see the
And the
smoke.
bigger glass
Big is
had...
still going.
Is it because it had more space and that's why it took the longest?
Well, that's what we're talking now. If we went back to the fire triangle, which one of those things would be cut off? So if we looked at your fire tetrahedron, we stopped the
Oxygen,
chemical
right?
reaction. Yeah. So
We blocked oxygen.
and it makes sense that this one ran out of oxygen first because it's smaller. The smallest glass ran out of oxygen first because it's
Okay.
smaller, and then this one went out because it's next smaller, and then this one went out because it had the most oxygen
So
in it.
first, second,
and
third,
third, right.
this had
So-
the most oxygen.
Yeah, and
That's
so
why
this
it
one
lasted
used
the
it up. Yeah,
longest.
so that's why that lasted out. So that shows, that's kind of a fun demonstration to show you how the oxygen is part of that combustion or that fire
Very cool.
tetrahedron.
And the smoke.
And the smoke is in there too, yeah.
Cool.
So
Remember, if you have math or science questions, you can put it on the chat,
Uh-huh.
the live chat on homeworkhotline.tv,
right,
and then we will check it and we can answer math or science questions.
right.
All right.
Now
Some
one of
more
the
fire?
other cool things is just if we can get we'll put these together, so maybe, is just looking at the flame itself. It's pretty neat. So if they can come in on a tight one.
Yeah.
Um,
Good close-up of the flame.
Oh, nice shot. I'm going to move that one so they can see. So you can see different colors in the flame too. So you can see the yellow that's on the outside. I'll do like on Antiques Roadshow. I'll use my stick. So we have this nice yellow color here, and then blue in the middle, and then and the kind of a red in between there. And so you can see different things are happening and different heats that are going on too.
Oh,
So
you can barely see the blue, but
yeah,
it's there.
you can see, yeah, with the bright lights in here. So I'm going to try and put up a little card and see. And the other thing you can see, I'm hoping with the lights with a close-up is you can see sometimes you can see the actual shadows of the, okay.
Yeah, we won't try that.
Okay, it won't do on that one?
Yeah,
Okay.
I don't think it'll look, it'll
It'll be
wash
too
it
bright?
out.
Okay. So now if we have a cool graphic that we can go to that is kind of a close-up and tells you what's going on. So the hottest zone, so if you're trying to heat something up, oh, awesome, would be at the very top. And then the middle zone, you can see it's kind of that white or blue as we're looking at. And then the inner zone is there's very little combustion there because the oxygen can't get to it. One of the things that I forgot to add on our list is that in space, so what's happening is also the hot air is coming in, it expands, and so it goes up, and so the flames are kind of take on that because of the hot air is being pushed up by the cold air. In space, this doesn't happen. It actually just turns into a ball.
Really?
Yeah, because there's no convection currents, because there's no gravity pushing the other air in there. So it just kind of makes this cool little ball in space. So
Is
let's
that
try
why
this.
the sun looks like it does? Like it?
Yeah, well, everything, and I think that's the most unique shape. And then if we can come in close and see, I don't know if you can see it or not. So what I was hoping to see, now you can't really see the shadow. Is that you can try this at home with a bright light. Don't hold the paper too much, but you can see the shadow of the flames. And you can see, I'm going to try and sneak this in there and see if it'll show it or not.
No,
way too
that's
bright. But you can see things that you can't see with your naked eye. The other thing you might try is to take pictures with your camera. Because it's got more of an infrared, and you'll get some neat images going on there.
Okay.
So again, we're homeworkhotline.tv, and go there. And I think we have a question about what's a perfect square?
Yes.
All right,
Cool.
That's a good question.
That is a good question. I just talked about this today with one of my students. We were completing the square, which that might be a little bit more challenging. But a perfect square, you can have the shape, that's a square, okay? And then if you have the length of each square, or the side of the square, and if you wanted to know the area inside here, would be 2 times 2. Let me use the little x for multiplying, which is 4. So 4 represents the area inside the square, and we call 4 a perfect square.
Oh, nice.
So
some of the numbers that are perfect squares are...
So 2 times 2, another way to write it is 2 to the 2nd power, or some say 2 squared.
Nice.
Okay, perfect squares, 3 to the 2nd power, 4 to the 2nd power. All of these answers would be considered perfect squares.
Nice.
Because they represent area inside of a square.
So neat. So it's a real almost geometrical or pattern that is showed represented by the numbers. Very cool.
And then with one of my Algebra 2 students today, we were completing the square.
So how did you do that?
Well, you really want to see that?
It's up to you.
We'll see.
Okay.
We'll see if we have more questions, and then I could do completing the
Completing
square.
the square. Okay, that sounds good. So, the other thing to compare is that you'll notice is try. This is an alcohol burner, and I want to see if we can get a different colored flame out of this or not. So, so let's light this.
Alcohol, like rubbing alcohol?
It's got it's an alcohol, or it's a lab burner, but it's got like a isopropyl alcohol inside of it. Yeah. And you can see. Let's let that build up a little bit.
I'm not sure.
What I might
Maybe
have to do
if I
is
stand here,
let's
you
try.
can kind of see an orange come out.
Yeah, and so you can see.
There, that's
I'm
better.
going to try this. Hold on. Get a little bit more of
the wick?
The alcohol on the wick, yeah. So I'm going to turn it over and try and get some more in there. There we go. Okay, now we'll try it. Okay. There we go.
Oh, that's a much bigger flame.
Much bigger flame.
I'll hold the...
Okay, yeah. And so you can see that it's got a different color to it, and because of the different chemicals. So it's definitely got a reddish glow to it almost.
Is there a circle on there? Or is that
yeah, and it's not as much. It doesn't have the as much air rising, perhaps because of the size of the base. That it's real big rather than sharp.
Gotcha.
But what's neat is there's a whole science of the colors that things put off. Different elements do. So every element actually has a different fingerprint of colors behind it. It's a little better, but still, no, it's just not clear.
It's more
but
like an orange.
Yeah, but there's oranges and blues in that one. So, and then maybe I'll try and bring in some salts and things. So fireworks are an example of that. The reason that you get those beautiful colors in fireworks is because of the
different chemicals.
The different chemicals that they put in them. So if they want pretty greens and stuff, they use coppers and other chemicals for different things like that. So there's a different one for that. So, all right, we did that. And then another cool demonstration to show part of the fire triangle is we're going to try. You can take a pair of tweezers with your, and these are things you can do at home, but make sure your folks are aware of what you're doing, or their best yet is do it with your parents. So what you do is, we can both do it.
Okay.
Is you go right to the base of it, and with a pair of tweezers or forceps, you kind of squeeze it, and you'll notice that it goes out.
Away.
Yeah. So what? Yours came back on. That's cool. So again.
All right. So I'll see. So
just at the very base, squeeze it, and then. So what am I doing, or what are we doing, when we squeeze it there?
Taking away
we're taking
the
another part
fuel?
Yeah, we're taking away the fuel. So the wax, as your candle burns, you'll notice at the bottom of your flame there's always a pool of liquid wax, and that's actually what is burning. And so if we can take the fuel out of the fire tetrahedron, we stop the chain reaction or the chemical reaction, and so we can actually do that. So with when you put out a fire with water, what it does is it stops the oxygen, and it also takes away the fuel as it covers it. So a lot of fire extinguishers do those things, is that they either interrupt one of the elements of the fire tetrahedron, or the elements to stop the chemical reactions from happening by either coating them or taking away the oxygen, or you take away the fuel like we just did.
So on our candle, the wax.
Yeah, the melting
our
wax
fuel.
is the fuel. Right, very good.
Okay.
And oxygen coming from the atmosphere, and then the heat. We started it off with our lighters. So the fires always have to have some sort of a reaction that actually starts the combustion for happening. So do we have any comments? Let us know that you're watching if you're out there too. I would like to know that the system is working, and it's always good to get a little feedback. So, and then this is one of my favorites, okay, is that, so what you're going to do here is, you got that one.
Okay.
Want to try that one?
All right.
Is we're going to use our snuffers, and we're going to try to
Take out.
do that actually, and let's put them more or less together so the cameras. I'll put mine over a little bit. There we go. We're gonna, and then you need a candle to help you.
Okay. So a little
Okay.
candle.
So what we're
I
gonna
need
do
it
is
lit.
snuff it, and then what's neat is that you'll see that the flame will actually go down. Okay, let's see. Let's put that one out. Oops. And you see
Wow.
that the flame actually jumped down.
I saw
You want to
that.
try it?
Okay.
let
So
it put it out.
take out the
Yeah.
flame.
And then you have to try and get the smoke.
Light
catch
the
it.
smoke.
Yeah, you have to do it pretty fast.
Ah. Okay.
You have to do it really fast while the smoke is still there. Yep. So that one actually jumped sideways. So if we can get the cameras to come in real close, it's neat to see the reactions that are coming in. Okay, so we'll put that out. Oops. So you can see it jump down. Sometime, and that was like a.
I was trying to blow the smoke that way, so the camera would catch
Oh yeah,
it.
catch it. Try it. So you got to do it a little faster. So don't put the thing all the way down. Oh, but that's good.
Yeah.
So just kind of try
Never
and cut
knew
the
that. Why
oxygen
does
off.
the smoke?
So that shows what's actually burning is the vapor. Is the wax is actually turning to, the heat is turning there you go. Oh, nice. That was a good one.
I don't
And
know
if
if
you
they can see it on
practice-
camera as well.
You can
There.
see it kind of jumped.
Is that why when you have a birthday cake and you have a whole bunch of candles, like you're
Yeah,
really
sometimes
old,
they're hard.
you blow it out and then they come back?
It might be if there's one left over. And it's also kind of a flashpoint. There's another thing for if you get the temperature of material just right, it'll burst into flames. The activation energy is another fancy word for it. So that shows that what's important is not just the wax that's burning there, it's actually the wax vapor that's burning off of here. So if I do that, if I take away the fire, you can see it'll jump way down. And if you've got a big candle, sometimes you can get this to do. And again, this is one you can try with your family, but definitely don't do it by yourself without somebody knowing what you're doing. And outside is best.
Very cool.
Yeah, so that's another neat one to do. So it's trying the different ones. So and that shows, that's part of the thing too, is that here we've got the fuel that's in a vapor form. Part of the chemical reaction or the chain reaction that's happening is you can actually put, if you were foolish enough to do it, if you had a bunch of gasoline, a pan of gasoline, you could put a match out in it if you can get it go faster than past the vapors, because the vapors are what will set it on fire really fast. So
Gotcha.
that's a different one. So, all right. So there's another neat thing. This is just kind of a fun demonstration to do that relates to. I'm going to light this candle, and you're going to put it in this way after we get it lit. Okay. And I'll hold it. Okay. We'll get these out of the way. So I'm going to try and put that so that the camera can look at it, and we're going to light it without lighting you.
Thank
And
you.
if we put it down into the test tube,
Okay.
kind of slowly, or yeah, you can go ahead and put it in. You'll see that after a minute,
Doesn't have enough oxygen?
yeah. So what's happening is that it's using the oxygen that's in the tube. Go ahead and go all the way to the bottom and see, and you'll see it'll go out eventually. So that the oxygen, oh no, it's still burning a little tiny bit, but eventually it'll go out. I've got wax in there.
Oh,
But
yeah.
then there's a neat thing, this is the surprising thing. I'm going to put this little piece of aluminum foil, and some lamps do this, is that you'll see a little divider in them. So we're going to do the same thing, except
Okay.
we're going to follow, so put that kind of right next to it,
Okay.
at the same time, and then put that into the flame. And then you'll see that the flame stays going. It stays the same side, so it's not struggling. It's still got lots of oxygen. I'll move my fingers out of the
So
way.
is the oxygen,
So what's happening is the hot air is going up on this side, I believe. And can you rotate it a little bit? I think that
this way?
There we go. And then so the cool air is coming down on the other side, and so it's got a constant supply. So before, with just the candle inside, all the hot air is rising, and it's not allowing any oxygen to go in. But just putting that little divider inside causes it to be able to work.
Wow.
So I'll draw a picture of what I think is happening. So
Okay.
can I erase your square stuff?
Yeah.
Okay. So this is my test tube, nice orange. Okay. And if I put my candle in here, okay, make my flame. Okay, so what it's doing is it's the oxygen is surrounding it, but as the hot air rises, it doesn't allow oxygen to come in. Okay, so it's all going out and nothing's going in. So there's no in going in this way. So this is all the hot air is going up and there's no oxygen coming in. But if I can put that little divider in there, okay.
So hot air is still going to go up.
Yeah, so hot air still goes up on this side, but with that divider, then now the cool air can push its way in.
And
so
come
this
down.
So this is,
Cool air.
yeah, oxygen, O2 is going out, and then this is actually CO2 and water plus H2O is going out of it. So, it's just a neat phenomena, a physical phenomena of making sure that you have oxygen coming in to make that all three of those go on in the heat triangle. So
Do they use that in real life, like anywhere, like?
I think I've seen some lamps that have that, like for camping lamp, for the ones that don't blow out. I'll try and bring some in from our camping stuff, but they have like.
Remember the old lanterns?
Uh-huh.
Where they have like a wider base and then a
Right.
skinnier.
Yeah, and I think that wider base is for that thing too, so the convection. And then the old lamps have holes at the bottom too.
Holes at the
Yeah,
bottom where.
so the air can come in
All
to
right.
it too. So, and even Coleman lanterns, the same kind of thing. So.
There's a cool
Yeah,
picture of some
and that's a
lamps.
Davy Lantern, which is the next thing we're going to talk about. So this guy named Humphrey Davy, Sir Humphrey Davy, I think he got a Sir out of this, is that he found out that if that gases especially have a combustion point, is that things don't burn until they get to a certain temperature. So the application that he was especially interested in is in the coal mines of England, or all over the world at that time. Coal was the #1 supplier of energy that powered steam engines and everything else. That methane gas would get in there. It was called coal deep, and it was very explosive. And so a lot of miners were dying because of they didn't have electric lights at that time, and so they used headlamps that had like an oil in them. And the bad thing about that is if you got a flame and that you have a flammable gas, then it tends to catch on fire.
Start on
So what
fire.
he found is if you have a wire that you can actually stop the flames. And so if you can do a close up again, you'll see that the flames actually stop. I stop the combustion from going through, pretty much so on that, and I get all this smoke, which shows that it's not, and that actually makes it cooler. And so he invented this thing called a Davy Lantern, which we're going to try.
And then are we going to finish it on Thursday?
Yeah,
Probably?
and this one hopefully
Okay.
will be a fun. How much time do we have? About
Yeah.
1 minute.
A minute.
Minute 15. Well, we'll try it and see.
Okay.
So this container I have is full of a flammable liquid, and then so I have lots of the gas in there right now. And then so this is a recreation that I have of Mr. Davy's lamp
Okay.
over here, I think. So I'm
We'll
gonna try
start it
this real
today and
fast.
then pick up again on Wednesday.
Yeah. if we don't get to it. And so with Mr. Davy's lamp, he just had a wire screen around it.
Okay.
And we're going to put this in here. And we're going to put on our goggles. And we're going to ask the people in the studio to put on their goggles too, so we're all safe. And we're going to put up the blast shield so that the cameras are safe. Can you hold that for just
on
a
the
second?
top? Okay.
Yeah, it might get hot.
It is a
We'll
little
try and
hot.
get this through real fast.
Okay,
And
here's
my
your goggles.
Okay. And we're going to try and put this in there with no result.
And there's a flammable liquid in there, but it's not going
Yeah,
to
but it's
start
not
on
doing
fire.
it. But now we're going to try putting in
Okay.
one that's flammable. And you'll see.
We'll see you guys. Whoa! That was amazing. See
See you
you
Thursday.